Let's talk about the Le Chatelier's principle. When a system is at equilibrium, this equilibrium can be disturbed by an external influence. Then the system take action to reduce, to offset, to avoid this stress and will come to a new equilibrium. When this the process, this the process is known as the Le Chatelier's principle. When a system is in equilibrium, the equilibrium can be disturbed by an external influence. Then system will take the correct action to offset that stress. It is known as the Le Chatelier's principle. The system say can maybe the equilibrium shift to right when the Q gets less than the K, or system will be shift to left or the reverse direction when the Q get greater than the K. Let's see how we can apply the Le Chatelier principles on the different systems. The equilibrium can be changed by changing the concentrations, pressure, and the volume and the temperature. All these things can change the change an equilibrium. Mm, Look at this reaction. The tetra-aqua copper complex, it's blue, is in uh, equilibrium with chloride ions and forms this tetrachloro copper 2 plus complex, which is yellow. So this equilibrium, the mixture is blue-green solution. What is the first thing that we should do? Yes, we need to write the equilibrium constant expression for this reaction. Yes, check whether the reaction is balanced and get the coefficients appropriately, and you write the multiplication of concentration of products in the numerator raised to the power of coefficients divided by the multiplication of the concentration of the reactants in the denominator, which is raised to the power of their coefficients. Next, what is this one? Yes, that's the concentration of a liquid thing. It's a constant. Yes. So we get a new equilibrium constant. Actually, now in the equilibrium constant expression, you will observe the water. Concentration of water is not included. Okay, good. Right. Think now the system is in equilibrium, but we disturb this equilibrium by adding excess chloride ions. Where is chloride? What is a chloride ion? Yes, it is a reactant. System doesn't like that. So what does system do? What does system want to do? Yes, system wants to reduce the additional or this excess amount of chloride. Then system needs to consume this. Yes, the system then needs to move forward. Yes, consume the additional chloride and more products. So we'll see the producing of the more yellow complex. The equilibrium shift towards products makes more yellow complex, and the solution becomes more green because more yellow is in the mixture. Next, same equilibrium, same reaction, same equilibrium constant. Now we'll add the Ag plus silver ions. You would think no, the equilibrium won't disturb because we don't see the silver ions in the reaction. But the silver ions reacts with the chloride ions and precipitated as a silver chloride solid. It takes out the chlorines. So addition of the Ag plus the silver ions actually reduces the concentration of the chloride ions. Does the system like this? No. what does system want to do? Yes, system wants to make more chloride ion. Then what does have to what does it have to do? Yes, it needs to make more reactants. So the equilibrium shift towards the reactants, making more blue complex. Right. Okay, next, addition of water. Do you see that actually the water component in the equilibrium constant expression? No. So the addition of water doesn't make doesn't change the equilibrium. No change in the equilibrium. Effect of pressure and volume changes on equilibrium. Right. Let's consider gaseous system at constant temperature and moles. The production of ammonia using the hydrogen and nitrogen. The reaction is balanced. Okay, we write the Kp, uh, the pressure of the ammonia squared divided by the pressure of nitrogen times the cubic pressure of the hydrogen. What would happen if volume is reduced? Ah, we in the Kp expression, we have all the parameters in pressures. But it does say that it is said that the volume is reduced. What is the effect of volume on pressure? Yes, then the pressure will be increased. That's how you need to take. From the Boyle's law, you know that they are indirectly uh, proportional. So if the volume is reduced, the pressure will be increased. Now we have excess pressure in the system. System was in equilibrium, so the system doesn't like this. System wants to reduce that pressure. So in order to reduce the pressure, look at the each side. Yes. Look at the which side has the less moles of gas, because when there are more molecules, that side has higher pressure. If a side has a fewer molecule, then the pressure is low. When you look at the reactant side, 3 moles of H2, 1 mole of N2, 4 moles. Product side, there is only 2 moles. So which side has the reduced pressure? Yes, the product side. Therefore, reaction favors the product side in order to reduce the excess pressure that has been caused by the reducing the volume. That's how we apply the uh, Le Chatelier principle to think about where does this new equilibrium exist. Next, we'll look at the effect of change in effect of the change in temperature. This is a system using again use the same reaction tetra aqua copper 2 plus in equilibrium with the chlorine and the tetrachlorocopper 2. So aqua complex is blue, chloro complex is yellow. Reaction is endothermic. That they said the reaction is endothermic. What is endo? Yes, we need to give the energy in. So if it is endothermic means the heat is a reactant. Heat is a reactant. If it is an exothermic, then the heat is a product. So adding heat, what does it mean by adding heat? Yes, more reactant. Then the equilibrium shift towards the product to reduce the temperature. Cooling, yes. Then system needs to warm up. Then needs to make more reactants, more heat. So the equilibrium move towards the reactants. Again, look at this equilibrium. This is the melting. So it's an endothermic reaction. So endothermic means the energy is a reactant. So adding heat means the reaction shift right side towards the products. Again, here is another reaction. Now it's an exothermic reaction. Therefore, energy is a product. So adding heat means we need to remove the product, so the reaction moves towards the reactants. How does a catalysis will change the equilibrium? Catalyst speeds up the reaction by changing the activation energy. So it changes that the activation energy for both the forward and the reverse reaction. Therefore, adding a catalyst doesn't change the equilibrium constant. So it doesn't even change the position of an equilibrium system.